Okay, 1.4, we're finding limits from tables. So for example, one, it says, according to the table, what is the value of the limit as x approaches -4 of f of x? -4 is not in the table. It would be somewhere between here and here. When you're creating a table, the x value should be getting very close to -4. So let's check from the left and from the right. Okay, if I start from the left of -4, I'm starting over here. This is x is approaching -4. As x is approaching -4, the y values appear to be approaching 2.5. Now let's check from the right side. Okay, I'm checking the -4 from the right side, from the positive side. It looks like in this direction, the y values also look like they're approaching 2.5. So from a table, all I can get is approximation. But my guess is the limit as x approaches -4 of f of x is it's approaching 2.5. And it should be fairly clearly approaching it if they give you a table. Okay, let's look at example 2. We're going to evaluate the limits using the table. Okay, the limit as x approaches 3. So in the x's, there is no x equals 3, and it doesn't matter if there is because it's useless to me. Okay, if I approach, x is approaching from the negative side, the y values look like they're approaching maybe 6. Okay, if I come from the positive side, the y values look like they are approaching 7. So the limit as x approaches 3 does not exist because one side is approaching 6 and one side is approaching 7. Okay, now what if we only consider the limit as x approaches 3 from the negative side? Negative side is a little lower than 3. So from the negative side, the y values do look like they're approaching 6. So for this one, I would say the answer is 6. As I approach 3 from the positive side, the y values look like they're approaching 7. So the limit as x approaches 3 from the positive side of h of x equals 7. But since the left and right side do not match, the limit as x approaches 3 of h of x does not match. Okay, so for example 3, it says if f of x equals x cubed minus 4x squared minus 7x plus 10, the quantity over x plus 2, use a calculator to make a table to help evaluate the limit as x approaches -2 of f of x. Okay, since I want the limit as x approaches -2, I want the numbers to come very close to -2. So I'm going to put -2 in my table. Okay, and then I want the numbers on the left to be a little bit lower. So let's get kind of close, maybe 2.001, -2.01, -2.1. I'm trying to get farther and farther away to see if it's coming close. So then from the positive side, -1.999, maybe -1.99, and -1.9. I'm looking for like a pattern. Okay, I want the limit as x approaches -2, which means I actually don't care about the value when x equals -2. So I'm not even going to put it in the calculator because it's most likely going to confuse me. Okay, so depending on your calculator, I'm going to go to the y equals or the graphing function. I'm going to enter this equation, and then I'm going to use the table function to evaluate them at each point, and I will show you how to do that in class. Okay, so I'm just going to write down the numbers I get. And depending on your calculator, you might have more decimals than me. Okay, so these are my y values. So as x is approaching -2 from the left side, these numbers look like maybe they're going to 21. Let's check from the right side. Yes, that does look like it's approaching 21. So I'm going to conclude that the limit as x approaches -2 of f of x is about 21, and that's just an estimate based on my table. Okay, so for example, for the function f is continuous and increasing for x is greater or equal to 1. The table gives values of f at selected values of f, x. Approximate the value of the limit as x approaches 2 of the cosine of f of x. Okay, this looks weird only because of the cosine part. Now cosine is continuous, so I don't actually have to worry about discontinuities there. So we're going to make this into, are we going to make this a composition? Let's look at it the way it is actually. Okay, first let's apply this to this part. Okay, what is the limit as x approaches 2 of f of x? Because the table only gives me information about f of x. Okay, I'm going to say, let's look at this. As x approaches 2, looks like the y value is going to 5, and it's going to 5. So I think the limit as x approaches 2 of f of x is approaching 5. So now, even though it's weird, instead of saying the cosine of 5, although I could because it's continuous, I'm going to rewrite this as the limit as x approaches 5 of cosine of x. Okay, because I found that the limit as x approaches 2 of this is 5. So now I want to figure out what happens as the limit as x approaches 5 of the cosine of x. Since cosine is continuous, I can just plug the 5 in. And then depending on if they want an exact answer or an approximation, I could leave it as cosine 5, or I can put it in my calculator and call it 0.2837. You could leave it like this, or you could put it like this because it does say to approximate it. 1.5 piecewise functions, we're going to evaluate the limits from the left and right and the regular limit of piecewise functions. So example 1, f of x is, and when x is less than negative 5, I use the square root of 95 minus x. When x is greater or equal to negative 5, I'm going to use 2x squared plus 8x. Okay, so for a, I want to approximate the limit as x approaches negative 5 from the negative side of f of x. Since I am approaching negative 5 from the negative side, I want to think about if that is a little bit less than negative 5 or a little bit greater than negative 5. It'd be a little bit less than. So I'm going to use the first function. And I'm going to go ahead and use direct substitution. And I always use direct substitution unless there's a problem. So I'm just going to plug in negative 5, which is the square root of 100, which is 10. So the limit as x approaches negative 5 from the negative side of f of x is 10. Okay, now let's check the limit as x approaches negative 5 from the positive. So if I'm coming from the positive side, I'm coming from the part of the graph that is a little bit greater than negative 5, which means I need to use this function. And I'm going to use direct substitution unless I have a problem. So what is that? 2 times 25. That is 50 minus 40, which is 10. So the limit as x approaches negative 5 from the positive side of f of x is 10. And what is the limit as x approaches negative 5 of f of x? Well, negative 5 is where the two functions meet. So normally you need to check the left and right side. So on the left, I got 10. On the right, I also got 10, which means these graphs are meeting up at 10. So the limit as x approaches negative 5 is going to be 10 because the left and right limits both match. Okay, let's try one more piecewise function. Okay, this one says the limit as x approaches negative 1 of g of x. Okay, now negative 1 is where these two functions are meeting. And actually, when x equals negative 1, it doesn't even exist, so I'm not even worried about that. So to check, what happens is the limit as x approaches negative 1, I need to check the left and the right side. Okay, so if I plug in negative 1 from the left side, I get 10 minus negative 1 squared, which is the square root of 9, which is 3. Okay, now if I check the next piece of graph, this one, and I plug in negative 1, I get 26 minus 5 times 1 over 7, which is 21 over 7, which is also 3. So since they match, the answer is going to be 3. Okay, let's do the next one. The limit as x approaches e from the positive. So the positive means I'm coming from the graph that is a little bit higher than e. So I want to do x is greater than e. So I'm going to do the ln of e to the third power. What is ln of e to the third power? Some of you just know it goes to 3. Some of you know the 3 comes down. But if I do the 3 down, I do 3 times the ln of e. The ln of e is 1. So this is going to turn into 3. There's a lot of 3's in this problem. Okay, now C says the limit as x approaches e of g of x. Since e is a point where the two pieces are connecting, I need to check the left and right. I already checked from the right. The answer is 3. Let's check from the left. From the left, I'm using that fraction. So I'm going to get, I need more space. 26 minus 5e to the third over 7. Okay, I don't know what that equals to, but does that equal to 3? No. So the limit as x approaches e of g of x does not exist because the left and right sides do not match.